Hi everyone. This is our first session in our Math 012 class. And as I have stated in the syllabus, um, I'm going to do a lecture and post it on Moodle every week, probably 2 or 3 lectures per week. And then there is a follow-up, meaning what? I'm going to give you an assignment and you're going to do the assignments and you're going to turn it on the due dates. You're going to take pictures of your assignments and then you can email it to me. If you have any questions like in doing the assignments, you can let me know through email, or if you choose, we can also do Zoom chatting. Okay, so I hope this is going to be a productive semester. If for any reason you have problems of downloading or any other downloading the lecture or any other issues, please let me know. So we are going to start with the first concept, meaning what? What do we mean by real numbers? So this session is just giving you an idea of the terminology that we use in mathematics. Okay, but before we go into real numbers, probably you know about this through high school. We need to define and then this goes all the way to infinity. So meaning what? I'm writing now numbers that start from 1 and jumps to 2, 3, 4, 5 and goes up to infinity. This set of numbers, we call them counting numbers. Or you can also say natural numbers. So if in case you see a counting number or a natural number, it is a number that starts from 1 and goes up to infinity. Okay. This is the smallest set in our real numbers. Now we're gonna start growing the number. So I'm gonna add 0 into my counting numbers. 3, 4, and 5. And this also goes up to infinity. Okay. Because I added 0, and 0 is a very interesting number. You don't count 0, so it's not a counting number. We count 1, but we can't count 0. So we have to give it a different name. Because we added 0 into a counting number, then now we have whole numbers. Okay. By adding 0 into our counting numbers, we change the terminology, it becomes whole number. Okay. Now, I have now negative infinity. By the way, the symbol this is called infinity, or it means forever. Number goes forever. That's why we have this symbol. So now I'm going to put -3, -2, -1, 1, 2, and 3. And now, you see now our numbers are expanding, in the universe. Now, not only do I have 0, did I add 0, I also added what? Negative numbers. So we have to change the terminology. And know also, these two sets of numbers, they have a beginning. The counting number has a beginning 1. The whole number has a beginning of 0. Here, they don't have a beginning. There is no beginning and there is no end. These are involving negative numbers. We call these as integers. Okay? look, we are expanding our universe. Okay. I want us to really look at this concept. Look, every counting number is a whole number because you have 1, 2, 3, 4, 5. You have 1, 2, 3, 4, 5. But every whole number is not a counting number, meaning what? The reverse is not 2, right? Every whole number is also an integer because you have what? 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. But every integer is not a whole number. So I want you to know that difference, the difference between the two. Okay? Now I'm gonna expand more. -3, -5/2, -2, -half, 0, half, and it goes up to infinity. Look what I'm adding to the negative numbers, what I'm adding to the integers, meaning what I have added fractions. So, meaning what? Now it's getting bigger and bigger. This set of numbers is called rational numbers. Okay? A rational numbers means what? Integers plus fractions. Okay? Again, the idea behind it is look at, again, the relationship and the difference between these two. Every integer is a rational number because you have -3 here, you have -3 here. You have -2 here, you have -2 here. You have 0 here, you have 0 here. You can put 1 and 1. But every rational number is not an integer. Okay? Now, before I do that, hold on a second. So, if you look from counting numbers, whole numbers, integers, and rational numbers, meaning what? All these are rational numbers because the rational number contains what? The counting number, the whole number, and the integer. This is the largest universe of all these four. Each of them are embedded in it. So you can do a circle, like for instance, if this is a rational number, the set of rational numbers, then the smallest set is the counting numbers. Then if you put another circle, this becomes integers, right? No, whole numbers. My apologies. Whole numbers, which involves 0, right? And then this one would be integers. Counting number, whole number, integer, rational number, right? Okay. Now, and then there is another set of numbers that are distinctly different from rational numbers. These are, I'm going to do negative the square root of 5. Negative the square root of 2. And probably add square root of 2 and pi and up to infinity. If you go into your calculator and plug the square root of 5, you will see a bunch of numbers after the decimal, meaning what? It will never end. The same also goes to pi. So all these numbers, we cannot describe them as rational numbers. So we call them irrational numbers. Okay. These are a new set of numbers. Now we are ready to define what real numbers In fact, I'm going to write it. So real numbers, by real numbers, we mean the irrational numbers and everything that we discussed earlier. Real numbers are rational numbers plus the ones that we just discussed, the irrational numbers. You know that the rational numbers are from negative to infinity, negative infinity to infinity, but they include the counting numbers, the whole numbers, the integers, and the fractions. So that is basically what we mean by real numbers. Okay? All right. As you know, when we discuss algebra, which we are doing, we also bring in letters A, B, X, and Y, okay, representing real numbers. From here on, when we are talking about numbers, we're talking about real numbers, right? And we might as well start defining properties, certain properties of real numbers. Okay. Properties of real numbers. Now, I can do this. If I add 2 to 3, it is the same as me adding 3 with 2 because I get the same outcome. 2 plus 3 is equal to 3 plus 2, which is equal to 5, right? So it doesn't matter which one I put first whenever I do addition. In other words, A plus B is the same as saying B plus A. Then we can actually define this as a property. So addition has some property, meaning what? It is commutative property. The property of addition. Commutative property of addition. If I multiply 2 by 3, 2 times 3, I can do it a different way. I can reverse the order. I can say it is the same as multiplying 3 by 2, which gives us, in this case, 6. Therefore, what can I say about multiplication? It is easy to multiply. A times B is the same as multiplying B times A. Therefore, multiplication is also commutative. Commutative property of multiplication. Okay? Addition is commutative. Multiplication is also commutative. Now, if I subtract 3 from 2, is that the same as subtracting 2 from 3? And as you can see, 2 minus 3 is negative 1, and 3 minus 2 is 1. So you're getting 2 different outcomes. What does that tell us about subtraction? Subtraction is not commutative. Okay? You can't switch the order and get the same outcome in subtraction. So subtraction is not commutative. The same thing about division. So for instance, if I divide 6 by 2, is it the same as dividing 2 by 6? No, it is not, because 6 by 2 is 3, and 2 over 6 is 1 over 3. So these are two distinct values. Therefore, we can conclude the same thing that we did for subtraction. Division is not commutative. Okay. Now, you could also see us adding 2 plus 3 plus 4. And now I'm having three distinct real numbers. There is an order when we have a parenthesis. So meaning what? We have to solve the one in the parenthesis first. So 2 plus 3 is 5, and 5 plus 4 is equal to 9. We got the same outcome. But now I'm going to do differently. So I'm using the parentheses for 3 and 4. In this instance, you are asked, oh, this is 2, and then 3 plus 4 is 7, and 2 plus 7 is equal to 9. So whichever order that I put, I would get the same outcome. So when this happens with three real numbers, we do what? So A plus B plus C is the same as saying A plus B plus C. Okay. And this we call associative property of addition. Now, we can do this. Now you have an idea, relationship between addition and multiplication. Now, so that means what? If I multiply 2 by 3 first, and then multiply by 4, I would get the same outcome by multiplying 3 by 4 first, and then multiplying it by 2. 2 times 3 is 6, 6 times 4 is 24, 3 times 4 is 12, 12 times 2 is equal to 24. Therefore, we can conclude the same way we did. A times B times C is the same as A times B times C. Okay, and this is also associative property of multiplication. Okay. So we discussed commutative, associative. Another one that we look at, now we can combine addition and multiplication. Now you know there is a close relationship between the two. In fact, multiplication is a shorthand for addition. So if you do 2 times 3 plus 2, mind you, I'm multiplying and adding. Let's do it two different ways. Let's add 3 plus 2. 3 plus 2 is 5, 2 times 5 is 10. So I got 10 as an outcome. But what does also this tell me? You distribute 2 to 3, and then 2 to 2, and then add them together. So let's do this. 2 times 3 is 6. And 2 times 2 is 4. And 6 plus 4 is equal to 10. So we have the same outcome. Therefore, if I multiply A by B plus C, is the same as multiplying A by B and A by C and add the sums together. So you're going to get the same outcome. So this is what we call distributive property. Okay. Distributive property. So these are the four preliminary properties of real numbers. Then we have something that we need to look at. This is not that hard, but just only to see it as a concept. If you do 2 plus 0, it gives you what? 2. Meaning what? If you add 0 to any number, it spits back to your number, back. So a plus 0 is a. So we have to name 0. We have to give it a name. So 0 is the additive identity. Okay. 0 is the additive identity. And if you look at multiplication, multiplication also has a number, which is 1. So meaning what? If we multiply 2 by 1, you get 2. 3 by 1, you get 3. It gives you the same outcome. So a times 1 is equal to a. Therefore, 1 is the multiplicative identity. Okay. Once we set up the identities, one more concept before we end this session. So, what should I add to 2 in order to get 0? You ask yourself. This is my additive identity. And of course, if you look, then it's going to be minus 2. Meaning what? You have to subtract 2 from 2 in order to get a 0. So meaning what? So 2 plus minus 2 is equal to 0. So any number that gives us back, if you combine them together, any 2 numbers, combined together, added together, and give us 0, they become additive inverses of each other. So if you have 2, if 2 is a number, then negative 2 is the additive inverse. The additive inverse of 2. Okay, so let's just define this. A plus negative a is 0. That means if a is a real number, then negative a is its additive inverse. You can do it backwards also. If negative a is a real number, then a is its additive inverse. Okay. Now, what should I multiply 3 with in order to get 1? Okay. And then if you look at it, it is what? 3 times 1 over 3. So meaning what? It's a fraction. 3 times 1 over 3 is equal to 1. Therefore, this 1 over 3 is the multiplicative inverse of 3. Let's define it. Let me just put this out. If a is a real number, then 1 over a is its additive, multiplicative inverse. Okay, so we can end this first session because this is a preliminary. It just gives you an idea what we will be dealing in the upcoming sessions or throughout the semester. So meaning what? Real numbers. So we know what we mean by real numbers and their properties. Okay.